In this video, we will generate the Taylor-Maclaurin series sum of the Fresnel integral sign using double factorial or factorial over the x values from -2 to +2. We begin with the formula, which is the summation of a times x to the power 4n plus 3, where a can be a1, the factorial, or a2. And the value of n is from 0 to infinity. In this case, we can start from 0 up to 16, which is good enough. We continue with the coefficients, which is our array formula, minus 1 raised to the power n, divided by, there are 1, 2, 3, 4, 4 parts of the denominator, starting with the first part, which is double factorial. Double factorial of 2n plus 1, so 2 times n plus 1. The second part times 2 to the power n, 2 raised to the power n. The third part times factorial n. This is factorial n, so factorial of n. And finally, the fourth part times 4n plus 3, so the quantity 4 times n plus 3, and enter. And we continue with the factorial, which is equal to our array formula, minus 1 raised to the power n, divided by, there are two parts. First part is factorial 2n plus 1, so factorial, there are two parts, factorial 2 times n plus 1. The second part is 4n plus 3, so the quantity 4 times n plus 3. Then enter. Their values are exactly the same. Now we complete the expansion, which is equal to array formula, series sum, that's series sum of the x values raised to the power, that's 4n plus 3. 4n plus 3 starts from 3, incremented by 4, because our values of n is 1, 2, 0, 1, 2, 3 times 4, so the increment is 4. And the coefficient. You can use double factorial or factorial. Let's use the double factorial. And we'll chart this. Insert chart. And we'll use scatter chart. Use row 1 as header, column A as label. We'll erase this. We don't need this. We need a space. Now for the series, we show the trend line. The type polynomial, and the polynomial degree is 8, so to the 8th degree. For the label, use the equation with a legend position at the bottom. And here's our trend line and polynomial of the Fresnel integral sign. We'll calculate this polynomial regression coefficients using Linest. To do that, we complete the Linest matrix, starting with the power. This is equal to transpose 0 to 8. And the elements of the matrix are array formula of the x values raised to the power 0 to 8. Enter. Now we can use Linest. It's equal to Linest dot y and dot x. Then enter. Now let's compare the coefficients of the polynomial regression. Starting with x to the 0, 0. Coefficient of x minus 8.38 times 10 to the minus 3. Coefficient of x squared, 0. Coefficient of x cubed, 0.38. Coefficient of x to the fourth, 0. Coefficient of x to the fifth, 0.0591. Coefficient of x to the sixth, 0. Coefficient of x to the seventh, 2.58 times 10 to the minus 3. Coefficient of x to the eighth, 0. So suppose we use the factorial, because right now we're using the double factorial. Let's use the factorial coefficients. We still get the same coefficients, polynomial regression coefficients, the same polynomial, same trend line, hasn't changed, and our dataset still the same. This completes the use of double factorial and factorial to generate the Taylor-Maclaurin series sum of Fresnel integral sign.